Improper integrals. How do we do improper integrals? Well, in this video, I will give you guys 8 examples of the type 1 improper integrals. And by type 1, we mean to integrate over an infinite interval, such as this. For the first one, we have the integral going from 0 to infinity, and then we have 1 over x plus 1 in the parentheses and then raised to the 3 over 2 power. And to deal with these kind of things, you just have to remember two things. First is the integration, and then second is the limit. That's all. So we'll just do the integration first. We can do u sub, let u equal the inside, which is just x plus 1. Differentiate both sides, du is just equal to dx. And we will just take this integral to the u world, but remember, this is x is going from 0 and then to infinity. So we will also have to take this to the u world as well. Okay, when we put 0 in here, 0 plus 1 is 1. That's for the u. And then when we put infinity here, infinity plus 1 is still infinity. So we'll have 1 to infinity in the u world. And then here we have 1 over u over, raised to this 3 over 2 power. And then dx is equal to du. And by now, we should see that this integral converges because we know this is actually from the p integral, where the p is 3 over 2, which is bigger than 1, and that's the type 1 situation. We know this right here converges. But let's just compute the value for this. And to do so, we can just finish everything in the u world, and you will see that it's easy for us to draw a conclusion for the limit. So I'm not going to write down the lim. I'm just going to write the infinity symbol along the way. All right, what do I mean by that? Just check this out. First, let me rewrite this as, we still have 1 to infinity, but rewrite this as u to the negative 3 over 2 power, and then just integrate that. Add 1 to the power, and we'll get negative 1 over 2, and divided by the new power, we just have to multiply by its reciprocal, namely negative 2 over 1. So you see, we will get negative 2, and then u to the 1 over 2 power, but that's negative, we bring that down to the denominator. So we have negative 2 over u to the 1/2, which is the same as square root of u. And right here, I'm just going to be plugging 1 and also infinity like this. But just keep in mind, when we plug in infinity, we are really taking the limit as u goes to infinity, that kind of thing. But technically, you should write it as like the limit as b goes to infinity, but it's easy for us to draw a conclusion, so let's just do it like this. If you're taking my class, then that's okay, right? This is okay. You're good, I'm good, yeah. All right, so here, plugging, and then the first term we get negative 2 over square root of infinity, and then minus the second term is negative 2 over square root of 1. All right, and what's this? Negative 2 over infinity, right? So that will be 0, and then this is just going to be plus 2. So minus times a minus, and then we have the 2. So ladies and gentlemen, the answer for the first one is just a 2. For the second one, we have the integral going from 0 to infinity of x squared over square root of x cubed plus 4. Can we do u sub? Yes. So let's do u sub. Let u equal this, x to the third power plus 4, and then differentiate both sides. Du is 3x squared dx. Divide this on both sides. Dx is equal to du over 3x squared. Then take this integral to the u world, the happiest place for integration, right? Alright, so we see when x is going to be 0 here, put it here, 0 to the third power plus 4 is 4. So we have integral going from 4, and put infinity to here, infinity to the third power is infinity, plus 4 is still infinity. So when x approaches infinity, you know u approaches infinity as well. And then here we have x squared over square root, and then this is the u, and then dx is that, which is du over 3x squared. And this is pretty nice, very nice. This and that cancel, so we can just deal with this, right? And we'll finish everything in the u world. However, if you remember the p integral, you should see that this right here does not converge because we have u to the 1 over 2 power on the bottom. P is less than 1, right? So it does not converge. But let's just say we don't know that. Let's just compute it and see what happens. We have 1/3, put it on the outside, and then we have the integral going from 4 to infinity. Square root of u on the bottom, it's the same as u to the negative 1/2. and then add 1 to the power, which is going to give us 1 over 2, divided by the new power, which is the same as multiplied by 2 over 1. So we get 2 over 3, and then we have u to the 1/2 power, and that's just square root of u, and then we will plug in the 4 and also the infinity. When we do that, we get 2/3 times the square root of infinity. This is the first term, and then minus plugging 4, we get 2 over 3 square root of 4. We can calculate this easily, but what's this? Square root of infinity is still infinity. 2/3 of that is still infinity. So in fact, here we have infinity minus 4 over 3. But guess what? This is still infinity. And you can say this right here diverges to infinity. That's okay. But I would just say this right here diverges. And that's all. That's all you have to mention. For number 3, we have the integral going from 1 to infinity of e to the 1 over x power over x squared. Can we do u sub? Yes, let u equal this guy. So let's go ahead and put that down. And we can look at this as x to a negative 1 power, because that way when we differentiate, well, we see this right here will give us negative 1 and then x to a negative 2 power, which is the same as over x squared. Alright, and then perhaps we can multiply both sides by negative x squared, so we get dx equals negative x squared du. So this is nice, because now we can go to the u world, the happiest place for integrations. Here, when x is 1, put it here, 1 over 1 we get 1, so that's a starting for the u. And then when we put infinity into x here, 1 over infinity goes to 0. So this is weird. 1, 0. Isn't usually we have like a smaller number here and then the bigger number here? Right? Okay, we'll see. This right here is e, and then 1 over x is the same as u, and then we have over x squared, and we see that dx is just equal to that, which is negative x squared du. So now we can cancel out the x squared, which is very nice. But notice, we have this negative here. And this is kind of useful, because in fact, we can use this negative to switch these two numbers. What I'm trying to say is the following. Have a look right here. If today we have a negative integral, suppose the numbers here are like out of order. Let's say we have b to a and then f of x. In fact, we can use this negative to change these two numbers. We can just go ahead and say this is actually the same as the integral going from a to b and then f of x. Why? Because remember, when we integrate this, meaning to find an antiderivative for this, we plug in the top number first and then subtract the bottom number, right? We plug in the b. But if you have a negative, it's just like the opposite order of the subtraction. So that's pretty much the idea. If you don't want to do this, it's totally okay. You just have to deal with this negative. But enough on that already. I will use this negative and change the integral going from 0 first to 1. I switch this, and I don't need to put on the negative anymore because of that. And then here we have just e to the u du. And now let's finish everything in the u world. We get, well, integral of e to the u is just e to the u, and then we have to plug in. This time we plug in 1 first. You see, we plug in 1 first. E to the 1, and then minus e to the 0. Oops, wrong color. If you didn't switch the order of integration, then you have to plug in 0 first, and then minus plug in 1. And then you have the negative on the outside. So just a different order. But, you know, in the end, you end up with the same answer. Be really careful though. Plugging 0 here, you end up with 1. So the answer is e minus 1. And this integral does converge, and converges to e minus 1. Number 4, we have the integral going from 1 to infinity, ln x over x squared. We cannot do u sub anymore. In fact, we will have to do integration by parts, because this is the same as x to the negative 2 power, and then times ln x. That's one of the forms that you should know that we do integration by parts. So of course, let's put that down on the side, d and also the I, plus, minus. Let's go ahead and differentiate ln x. and then integrate, well, not x squared, but rather 1 over x squared, right? Which is the same as x to the negative 2. All right, make this happen, we get 1 over x. Make this happen, we add 1 to the power, which is negative 1, divided by the new power, so we get negative, and then x to a negative 1, which is just 1 over x. So now you see, this times this is the first part of the answer, so we have negative, and then let's put down ln x over x. And then, don't forget that we will have to multiply these two things together and put that inside of an integral. Negative times a negative, we get positive. And don't you guys just miss that? Back in like pre-algebra, the teacher said negative times negative is a positive. That's all you have to learn, right? Good old days. But anyway, that, and then don't forget we still have to put down an integral, and then 1 over x times 1 over x, which is, well, let me just write it down for you guys just to show work nicely. Like so. And let me just finish this right here real quick. This is still negative ln x over x, and then this is the same as that, right? 1 over x squared, we have to integrate that. We get negative 1 over x. So work that out, you get negative 1 over x. We're not done yet, because remember, we have the limit of integration. So right here, technically, I should have put this down. We go from 1 to infinity. And right here, I should have still put down 1 to infinity. But what you can do is, just ignore that for now. Just do the integration by parts, and once you finish all that, and then you plug in the value, right, 1 and also the infinity. Here's the deal though. When you put infinity to here, what do we get? Well, ln infinity is infinity over infinity. That's technically indeterminate form, right? So we should technically put that on the side. So I'm just going to make a note on the side. If we take the limit as x goes to infinity, we do have a negative. You can put it down or not. Doesn't really matter because the answer will be 0. Whoa, what's this? What's the answer for this? 0. How come? Why is this 0? Why is this so easy? Yes, in my class, you can just say by the list. That's why I went over all that secret weapons with you guys. So, when we put infinity to here, I'm just going to write it down right here for you guys. We get 0, and then if you would like, you can just say by star, which is just a supplement on the side that you will have to provide. And then you can just write down the rest. Put infinity here, we have minus 1 over infinity. And then minus, put a 1, all that, right? So we get negative ln 1 over 1 minus 1 over 1. Okay. By the way, this right here is 0. Guess what? This guy also goes 0 because we can draw conclusion nicely. ln 1 is 0, so that's also good. Finally, people, negative 1. Negative times negative 1 is positive 1. So the answer for this is just positive 1. All the work for 1. Number 5, we have the integral going from 0 to infinity x over 1 plus x to the fourth power. Do we use u substitution? Yes. Shall we let u equal the bottom? Let's see. If we do that, well, differentiate both sides, we get du is equal to 4x to the third power dx. On the top, we only have x to the first power. This is 4x to the third power. So they won't cancel each other out nicely. Did I just make a mistake on the homework? Should this be x to the third power? No, I did not. It's meant to be x to the first power. Well, think about it. If this is x to the first power, u should be what? Something x to the second power. Because that way, when we differentiate the u, we'll get something x to the first power, right? So do we see x to the second power here? Now this is suspicious, huh? Yeah, that's the key right here. So we don't do this u right here. Here's the deal. We look at this integral going from 0 to infinity. X on the top over 1 plus, instead of x to the fourth power, let's look at that as parentheses x squared and then square. Ah, much better, right? Because this way we can just let u equal x squared, and then we see du is just equal to 2x dx. And by now, you know, so far I've been telling you guys, maybe let's just divide the 2x on both sides so you can isolate that, so you can see what numbers to divide and things like that. But we have done a lot of that already. I will show you guys perhaps a better way or quicker way, depends on how you like. So kind of, you can pick this up from now on. Anyway, we do have the x dx right here already. What we're missing is just the 2. So why don't we just multiply this by 2? So that way we can see the top is just the du. But of course, I cannot multiply out the 2 right here out of nowhere. It's okay. When we multiply the 2 right here, just make sure that we divide it by it. That way we still have the same exact expression. Right? So the beauty of this is that we see we have the 1/2 right here right away. And then again, this right here is just precisely the du. And then we just have the integral going from 0 to infinity. 1/1 plus u squared. And then we have the du on the side. Yeah. All right. And then we see this right here is just 1/2. And what's this? Inverse tangent of u. Yes. So we get the inverse tangent of u, and then don't forget we have to plug in now. So we plug in 0, infinity, infinity go first. So first term we get 1/2 inverse tangent of infinity, and then minus second term we have 1/2 inverse tangent of 0. Well, can we draw a conclusion right here? Yes, inverse tangent of infinity is pi over 2 because of the graph. It has the horizontal asymptote. And can we draw a conclusion right here? Yes, inverse tangent of 0 is just equal to 0. So as you can see, this is just 0, so we just have 1/2 times pi over 2. And that's going to be pi over 4. For number 6, we have the integral going from negative infinity to 0, x times e to the x. This is still improper. We just have to go from all the way to the left and then to 0, right? So still infinite interval. Well, the main question right now is, how do we integrate x times e to the x? Not use substitution anymore, but rather we do integration by parts. So let's put this down on the side. Of course, do the di, plus minus plus. We are going to differentiate x and integrate e to the x. We can integrate e to the x however many times as you would like. But don't do that, of course. Just stop right here, because you know, differentiating x one time we get 1, do it again we get 0, so we stop right here. Ladies and gentlemen, this times that will be the answer, right? So we know this right here will be x times e to the x. That's the first part of the answer. And then second part of the answer is minus e to the x. Okay, then we plug in 0 first. So we get 0 times e to the 0 minus e to the 0 first. That's the first part of the answer. And then the second part, we just plug in negative infinity and we subtract. But here's a small issue. If we put negative infinity here times e to the negative infinity, e to the negative infinity is the same as saying 0, right? So this is technically negative infinity times 0. We cannot draw any conclusion yet. We will have to supply some work on the side. So let's do it right here. Put the star, do the limit, and let's just use x. As x goes to negative infinity, and we have x times e to the x. And because this is a negative infinity times 0 situation, we cannot use L'Hopital's rule here. Maybe you can bring this down. So you see, this is the same as the limit as x approaching negative infinity, x on the top over, I'm going to look at the e to the x power as e to the negative x power on the bottom. That's cool. But you know what this is? It's going to be 0. You can use L'Hopital's rule, but you know the better way? You know it, you like it too. This right here is just going to be 0. Why? Because now you see both of them is infinity and also on the bottom is infinity. but this is just the other version of the list. So I'll just say this right here is 0 by the list. Secret weapon. Again, if you look at this as negative infinity, you put it here, that's e to the infinity, which is just, it's really the same as the list. It's just you have a negative, but it's really the same. So anyway, I'm just going to erase this right now. When you take the limit, right, negative infinity of this term, we get 0. And then I'll just indicate that by the computation here, so by star. And then we put negative infinity there. We will have minus e and then negative infinity right here. All right. Can we draw a conclusion here? Yes. E raised to a negative infinity. This right here will approach 0. Because this is the same as 1 over e to the positive infinity, which goes to 0. So luckily, the second part is just 0, and then for the first part here is 0, but we do have negative 1. Therefore, ladies and gentlemen, the answer for that is negative 1. Whew, a lot of work for just negative 1. But that's it. Number 7, we have the integral from 0 to infinity of cosine x dx. So of course, we can just go ahead and do the integration. The integral of cosine x is just positive sine x, and then of course we are looking at 0 to infinity. Drawing infinity, drawing 0, so we get sine of infinity like this. This is a really bad notation. I know that I said that so many times, but it's okay. It's just 除和做的 stuff. If you remember that we are taking a limit, then this is okay. But anyway, first term minus the second, we just have sine of 0. Now, this right here is 0, easy. But what's this? We do not have the limit for that. We do not have the limit for that. So, when we put 0 in here, if you look at the limit as x approaching 0 of the sine function, right? Because we are doing that to here, not to this, of the sine function. This right here does not exist. Why? Because look at the graph. Sine x looks like this. As x goes to infinity, the y does not approach to a number. So this right here is dne. Well, dne minus 0 is still dne, but don't do that. If this is dne, don't even look at what this is. Just say, you don't even say dne for this, don't worry about it. Just come back here and just say this integral diverges. But please, 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 don't ever say diverges to dne. That does not make any sense. Just put on diverge, that's okay, right? That's okay. So this is another kind of divergent integral. Like you just don't get a finite value. Yeah, it doesn't mean infinity though. It's just that you don't have a finite value that this is approaching to. That's all. Number 8, we are going to integrate from 2 to infinity of 1 over x squared minus x. How do we integrate this? Well, look at the bottom. Can we factor it? Yes. So yeah, partial fraction. And it's not bad at all, because once we factor it, we see we have distinct linear factors. So the partial fraction is not bad at all, right? Okay, so we look at the integral going from 2 to infinity, and the first fraction will have x for the denominator, and then for the second fraction, you will have x minus 1 for the denominator. To figure this out, which is going to be a constant, we look back to the original and cover the same denominator, and you ask yourself, how can we make x equal 0? X has to be 0. And you put 0 in this x now. 1 over 0 minus 1, which is negative 1. And then to figure this out, we go back to the original and then cover the same denominator, and you ask yourself, how can we make x minus 1 equal 0? X has to be 1. And you put a 1 in there. 1 over 1 is 1. Partial fractions. Now we can just integrate this. So we get, this is negative and then ln x. And we don't need the absolute value because we are going from 2 to infinity. So you know the x is going to be positive. Next, we have to add 1 and then ln this right here, which is x minus 1. And remember, you see that the coefficient of x is just 1, so that's why we don't have to divide by any number. Okay, technically divided by 1, but doesn't matter. All right, And then we go from 2 to infinity. And perhaps before we plug in infinity, we're going to combine the logarithms. Because if you don't, then if you have infinity, put it here, you get infinity and that's minus, and then if you put infinity here, you know that's also infinity, and you get indeterminate form. So we might as well combine the logarithms first before we talk about taking a limit. Okay, in that case we see, put a natural log here. This will go on the top because it has passed the natural log, right? So it's x minus 1, and then because the minus ln(x), so we will just have the over x right here. And then we go from 2 to infinity. But this one is not bad at all. You don't even have to do L'Hopital, even though you are taking a limit when x goes to infinity. Because you see, this right here, can we split the fraction? Yeah, so perhaps let me just write this down one more time. It's just ln 1 minus 1 over x. Very nice, huh? Yeah, 2 to infinity. Alright, put infinity to here. That's the first part. So we get ln parentheses 1 minus 1 over infinity. And then minus, we put 2 in here. So we get ln parentheses 1 minus 1 over 2. Alright. Now check this out. 1 over infinity, this right here is going to be approaching 0. And then we have 1 minus 0 inside of the natural log, which is going to be ln 1, and that will be just 0. 0 for the first part, very nice. So we know this right here converge because this right here is finite, and 1 minus 1/2 is just 1/2. So you can see the answer is negative, and then we have ln of 1/2. But you know what? Is this answer positive or negative? Technically, it's positive because, well, it depends on how you like to do it. You can look at the 2 as 2 to the negative power. So we have negative here, ln 2 to the negative 1. And then we can bring the power to the front. Do not minus 1 because we're not doing derivatives. We're just doing the natural log property. So you see, this right here is in fact equal to ln 2. You could have brought the negative to here and then just do the reciprocal. You will still get ln 2. Depends on how you want to do it. But anyway, these are the 8 type 1 improper integrals for you. If you need more help, check out my next video because I'll do the type 2 improper integrals. Okay? So I'll see you guys in that video. That's it.